Welcome to video lecture, section 1.3, decimals and percentages. The first couple of questions are going to be similar to sections part A, B, and C, numbers 1 through 3, 1 through 3, and 7 through 9. The first thing we want to do when adding is always make sure that the place values are lined up. So kind of a continuation from the last video lecture, here I can see I have commas here, which means that this 4 and the 9 are both in the ones column, so I'm good to go and go ahead and just start adding. So I'm going to add these together. 4 and 9 give me 13, so I'm going to put a 3 here, and up above here I will carry my 1, and I'm going to do that on my computer. It'll look a little funny, but there's my 1. It's not quite over top of, there we go, carry the 1, and then I'm going to add the tens place values, which 1 plus 1 plus 7 will give me 9. Oops, there we go. And then I don't have to carry anything there. Then the next one, the hundred spot, 5 plus 6, or 6 plus 5 gives me 11, so I will carry here. I'm going to come over, try and get these all lined up. There we go. I'm going to put a comma in mine as well. And again, I need to carry, so I'm going to come up to this position, give myself the 1. 1 plus 8 plus 3 gives me 9 plus 3 is 12, so I'm going to put a 2 here and carry my 1. And then again, just trying to keep all my place values lined up. In math, we work from the right to the left, or the right side when we're adding, and move to the left. And typing, it's not really working with me. So now I've carried the 1. 1 plus 2 gives me 3. And there we go. The answer is 32,193. Okay, let's move to the next one. This one, oh, and I'm going to double check that. There we go. And sometimes I highlight my answer. When you're working on paper and all throughout grade school, you were taught always circle your answer. Well, when you're working on the computer, you don't really have a quick way of circling. You could insert, and some people have the same option as mine, which is to review, and draw by hand. So you could do that, but I just highlight. In fact, I'm going to go ahead and draw by hand right now as we're working through the next one, so I don't have to keep working back and forth to get the numbers to line up. However, before I do that, I'm going to talk quickly about the place values here. Notice how the place values are not lined up. I don't have a comma here to show where the place values are. I have a decimal, and I need to add the place values together. So here is my ones, and here is my ones, and they're not lined up. So I need to move this one over. Now I have the option of doing that just by pressing the space bar. When you're doing this by hand, you will actually rewrite these and write it down so that your decimal and then all of your place values are all lined up. But now I'm going to go ahead, and I apologize for my handwriting, but I think this might be a little easier than trying to line everything up back and forth. So we're going to just go ahead and we're going to look at this 4. Sorry. We're going to look at the 4. Now it doesn't have anything that it's adding to, so working from the right side, 4 plus nothing gives me 4. And then 1 plus nothing underneath gives us a 1. But the next spot I have 6 plus 7. 6 plus 7 is 13. So, whoops, I apologize. Give us a 3. It's a little harder to do this on a computer screen than it looks, so I apologize for the handwriting. So 13, I need to carry my 1 and make sure that that decimal is completely lined up with everything. And then I go to the next one. The ones place values, 1 plus 2 gives me 5. And yeah, it's supposed to be lined up, but it's going to be a little bigger with my fingers. And then I have 1 plus 5, which gives me 6. So my answer is 65.314. And that does match my answer over here. So I'm going to go ahead and move on to the next one. 75,163 and 4 tenths, and we're going to be adding that to 34.5987. So again, I need to make sure that my place values are lined up. So here's my decimal here, and here's my decimal here, and I want my ones to line up. So I'm going to do my quick way on the computer, which you don't have the option of doing. And then again, we're going to start at the right and just move adding things up. So here, and I'm going to try and go a little smaller, we have 7. Nothing plus 8 is 8. Nothing plus 9 is 9. Then I have 4 plus 5, which is also 9, and a decimal. Then I'm going to add up my ones. We have 3 and 4, which gives me 7. Sorry. And then 6 plus 3, which is 9. And then the last 3, again, nothing's being added to those, so 1 plus 0 is 1. 5 plus nothing is still 5, and 7 plus nothing is 7. I apologize, those aren't lined up perfectly underneath as they should be, considering my, that's just how it is when I write things out. Okay, so I have 75,197 and 0.9987, which matches over here, and if I were to copy and paste that over here, it would look much nicer and everything would be lined up, which it should be when you're doing this by hand. All right, there we go. So that looks better. I'm going to go ahead and erase these guys. There we go. So everything's all lined up nice and perfect. Okay, let's move to the next one, number 4. These are where we hit the subtraction rules, and I'm going to go ahead and use my marking on this one simply because there's no way to show you what we're going to do. Whenever I see a subtraction sign here and a negative sign, these negate each other. If you have a subtract a negative, there's lots of different sayings and every teacher has their own. Some say add the negative or add the opposite. Some do say add the negative, but I like saying add the opposite. So what I do here, because these negate each other, and some teachers say change, change. I've heard it lots of different ways. So what we're going to do is we're going to change both of these right here. So this becomes an addition sign, and the negative becomes an addition sign. When I have 2 in a row, I can add the opposite. So in this case, I'm adding. The opposite of a negative is a positive. That's really my way. I like saying add the opposite. It's up to you, whichever of those ways you like best. So really, this problem ends up being 8 plus 6. 8 plus 6 is 14, which matches my answer. So I'm going to go ahead and move on. In this case, I have negative 52 minus 16, and that's kind of confusing sometimes. So what I'm going to do again is add the opposite. So right here, I have a negative or a minus sign, but the 16 right here doesn't say negative. So it's a positive 16. So when I add the opposite, the 16 actually becomes a negative. And you'll notice all of these problems that say subtract end up becoming an addition problem. So what I'm really doing is I have a negative number being added to yet another negative number. So I have 2 negatives being added, so I'm just going to add those together and the answer is going to be negative. So I have 2 and 6, which gives me 8. And I have a 5 and a 1, which gives me 6. Because they're both negative, the answer is negative. Negative 68. Okay, let's go to the next one. Here I have negative 31 minus a negative 3. It's a lot of negatives to wrap your head around. And remember, we're going to make all of these addition problems. So I'm going to add the opposite. I'm going to make this add, and the opposite of this over here, the negative 3, is a positive 3. Oops, there we go. Now, part of the problem here is a lot of students start putting positives out here. Do not touch the front number. It's off limits. What the negation happens over here in the middle. So if you have a negative sign, the next number following the negative sign from left to right, this one right next to it, that's the one that's affected. Do not touch the front number. Did you get it? I hope so. Don't touch that number. Okay, so now I have negative 31 plus a positive 3. So here we actually have two opposite values. So far we had positives, here we had negatives. Now I have a negative and a positive. Whenever you have a negative and a positive, after you've done the addition sign, this is where you actually subtract because they're opposite. So you subtract, you find the difference between the 31 and the 3, and then you take the sign of the bigger number. So here I have 31 and a 3. The difference between those, or just subtracting them, 31 minus 3, if we think about it, 31 can go backwards if you would like. 31, 30, 29, 28. So that was 3 down. So I'm going to come over here. The answer is 28, right? That's the difference between 31 and 3. If you're not sure, go ahead and count back up. 28 and add 3, 28, 29, 30, 31. So that was 3 more. Good, it matches. But is it a positive or a negative 28? In this case, it's negative because the 31 is more. Now, that was kind of a lot of rules thrown at you. One way to remember this is to kind of think about money. If I am $31 in debt and I add $3 towards that debt, then I'm only $28 in debt. So that's one way of thinking about it, and a lot of students like that way as well. But remember, we're going to change all of these to an addition sign, change the sign of the number following the subtraction if they are the same. So in this case, they were both positive, then you just add it. Here, they're both negative, so you just add them together and keep the negative sign. If they have opposite signs, negative and positive, or positive and negative, whatever it is, you subtract and take the sign of the larger number. Okay, let's move to the next one. Hey, this one it's been done for us, that it's already been changed to an addition sign. So now I need to look at the values here. I have a negative and a positive. So what do? Subtract. So I'm going to subtract here 21 and 4. What is the difference between those two? Give you a second to think about it. Or you can count down 21, count down 4, 20, 19, 18, 17. Now some of you would like to line those up, and that's fine. That's up to you. Some are going to be diehards lining up the place values and subtracting those, and that's just fine. You can do that. Here we have to borrow. So now I do 11 minus 4, which is 7. 1 minus nothing is 1. So the answer is 17, but don't forget you must go back and see which one has which is the larger number. In this one I have the negative being the larger, so the answer is negative 17. Okay, let's move to the next one. Number 8, 16 minus 32. Now some of you are going to just go ahead and say, oh, I know how to do that. But I'm going to go ahead and go with the rules that we've been doing and say I want to make this into an addition problem. So what I'm going to do is add the opposite, add this 32, I need to change its sign so it becomes a negative. Remember, don't touch the front number, he's off limits. Okay, so now I'm looking at a positive and a negative, which means I need to subtract. And some of you right now automatically know that 16 plus 16 is 32. Those of you who don't, that's fine. We can come over here and just do 32 minus 16. Remember, we're finding the difference between the numbers. I'm going to need to borrow, so I'm going to make this a 2, give the 1 to the next one. So now I have 12 minus 6, which is 6, and 2 minus 1 is 1. So this equals 16, but don't forget you have to go back and see which one is the bigger number. In this case, the 32 is bigger, so this is a negative 16. Okay, let's move to number 9. I have negative 17 minus 9. Again, I want to add the opposite. Add, don't touch the 17. Remember, we're moving from left to right. Add the opposite. It even goes in accordance to what I'm saying, adding the opposite. So adding comes first, then the opposite from left to right. So it follows the same order. Add the opposite. You don't opposite add. I hope you saw that from left to right. Okay, so now I have negative 17 and negative 9. They're both negatives. What do? Add them together. So I need to add 17 and 9. Adding up their place values, 7 plus 9 equals 16. Then I have 1 plus 1 is 2. And because they're both negative, the answer is negative. All right. Okay, now we're going to move to the next ones, which line up the place values for us, if you can see these. However, you'll notice that the bottom number is much bigger than the top number. What do we do with that? First of all, we had talked about previously adding the opposite. So let's go ahead and do that here. We're going to change this to add the opposite. So really we have a positive 610 and a negative 7,523. Well, what did we do when they were opposite? Come up here. We had a negative and a positive. We subtracted and then took the sign of the larger one. So here I'm going to subtract, and you're thinking, well, wait a minute. It already said subtract. Yes, but I can't subtract it like this. I'm going to set it up like we've done before, and then go ahead and take the sign of the larger number. So I'm going to set this up so that we can really subtract. 7,523 subtract 610. So now I do 3 minus 0 is 3, 2 minus 1 is 1, 5 minus 6, can't do that, so I need to go borrow. Borrowing 1 from the 7 makes it a 6. Give the 1 to the 5, so I have 15 minus 6, which is 9. And I'm going to put a comma here. 6 minus nothing is 6. So there we go, 6,913. But wait, I have to go back and make sure I take the sign of the larger number. 600 or 7,000? 7,000 is a bigger number, so I'm going to take the sign negative. There we go. And that's our answer. Let's move to the next one. Again, you'll notice the top one is much smaller than the bottom one. Again, we need to add the opposite, which would make this a negative 7,000. And what did we do? We subtract 7,510.7, subtract 628.4. And when we're done, take the sign of the larger number, which in this case is the negative 7,000. Okay, so now I have 7 minus 4, which is 3. I can't do 0 minus 8, so I need to borrow, which makes this a 0. And it makes that a 10. 10 minus 8 is 2. Don't forget to line everything up, so I have my decimal right there to line up with the other decimals. Again, I can't do 0 minus 2, so I'm going to have to borrow here, which makes that 5 a 4, and that 0 a 10. 10 minus 2 is 8. Now I move to the next one, the hundreds place value. 4 can't subtract 6, so I have to borrow once again. Make the 7 into a 6, the 4 into a 14. 14 minus 6 is 8. And then 6 minus nothing is 6, which is 6,882.3. Whoops, and my answer key is wrong. I apologize. I need to come in here and get myself a decimal. There we go. And don't forget, I have to go back and make sure I take the sign of the larger number. In this one, it's negative 7,510.7. So the whole answer is negative. There we go. So let's recap again. Make all of these addition problems. Add the opposite. Don't touch the front number. If the signs are the same, go ahead and add. If the signs are different, subtract. And if you need to line them up, go ahead, put the larger number on top, subtract the smaller number, then go back and take the sign of the bigger number. And there you go. That's a recap of how to subtract. Now let's come down to some of these story problems. We have something that costs $81.79. Tax was $13.92. We need a final price. So I'm going to come over here and just add things up. 81 and 79 cents. We need to add tax of $13. Notice I'm lining up the decimals so that all of the place values line up. There we go. Now we can add. We have 9 plus 2, making sure I've lined everything up. 1, carry. 1 plus, I'm actually going to do this in my head a different way. I'm not going to add 1 and 7. I'm going to add 1 and 9. Reason I'm doing that is that makes 10. And I know 10 plus 7 really quickly is 17. There we go. Carry my 1. Don't forget to line up the decimal. My next one is 1 and 1. 1 plus 1 plus 3, which is 5. And I don't have to carry anything, so now, oops, I forgot to put the plus sign, I apologize. 8 plus 1, which is 9. And because this one is giving us units, it told us that we're working with money, so I need to label this $95.71, which matches. Okay, let's move to the next one. Here I have a temperature of 85 degrees Fahrenheit. The change is 15 degrees cooler or colder. What will the final temperature be? Colder means that I'm going to be subtracting a temperature, so I'm going to subtract 15 degrees. 5 minus 5 is 0. 8 minus 1 is 7. So I am 70 degrees Fahrenheit colder. Or 73, sorry, not colder. I am 15 degrees colder. It's 70 degrees Fahrenheit, period. I apologize. We shouldn't say colder because it was already told us 15 degrees colder. Okay, let's move to the next one. Here we're talking about altitude. Altitude is the height of something, just in case you kind of are getting a little flustered with everything here. Just a quick reminder. So we have something that's 500, let's say meters, 500 meters. Let's not say miles because that's a little crazy. So we'll say 500 meters, and the altitude falls 225 meters. If it's falling, that means I need to subtract. 500 subtract the 225 meters that it fell. Because I have a 0 above the 5, again, I need to go borrow. However, there's nothing to borrow from in the tens, so I need to go over one more and borrow from the hundreds, making this a 4. But I can't go straight to the ones. That comes here because I only move over one place value, which means I need to still borrow, so make this a 9 and give the next one to the ones, so I have 10. 10 minus 5 is 5, 9 minus 2 is 7, and 4 minus 2 is 2, so the answer is 275 meters. Okay, the next one. We have a cost of $16.93 with a discount of $3.52. A discount means that I'm going to be taking money off. So I'm going to set this up. $16.93. Don't forget to line up the place values. So 352. My decimals are lined up. And because this is a discount, I'm subtracting. 3 minus 2 is 1. 9 minus 5 is 4. Don't forget to line up the decimal. 6 minus 3 is 3. 1 minus nothing is 1. So the final price is $13.41. Okay, let's try the next one. I have something at 23 degrees Celsius. There's a change 9 degrees warmer. Warmer means I'm going to be adding these together. 23 degrees Celsius plus 9 more degrees. 9 plus 3 is 12. 1 plus 2 is 3. So my final degree, oh, my answer is wrong over here. Again, I apologize. We need to go fix that. That should be 32 degrees. There we go, 32 degrees Celsius. All right, one more. The altitude, 5,280 feet, also known as 1 mile. There was a rise of 280 feet. If I have a rise in altitude, that means I'm going up further, so I need to add these. 5,280, oops, add another 280. 0 plus 0 is 0. 8 plus 8 is 16, so I carry the 1. 1 plus 2 plus 2 is 5. And 5 plus nothing is 5. So I have 5,560 feet. Looks good. Okay, let's move to the next one. These problems are similar to Part A, numbers 21 to 26, same as Part B, 21 to 26, and Part C, 19 through 21. Here we're given a fraction and asked to change it into a decimal. So this ends up being a long division problem. We take the top number and put it inside the division sign, 3, and we divide it by 4. There we go. Now, I know 4 cannot go into 3 because it's not big enough, which means I need to give myself a decimal and a 0. Now that I've given myself a decimal here, I move it directly above on the division sign up here so that they're all lined up. And then I start finding numbers that 4 can go into 30. Now we've done our multiplication so far. I know 4 times 8 will be 32. That's just a little over. So I need to be a little less. So I'm going to drop it down to 7. 7 times 4 is 28. Subtract. 30 minus 28 is 2. If you're not okay with jumping straight to that, you can go ahead and borrow. Oops, that's a 2. 10 minus 8 is 2, and 2 minus 2 is 0. I'm still not done, so I'm going to give myself another 0, because I can add as many zeros after a decimal that I want. It doesn't change the value. And then I drop down the 0. 4 goes into 25 times. 5 times 4 is 20. Subtract is 0. So we came to the end. The decimal is 0.75. There we go. Okay, let's move to the next one. So I have some room. I'm going to come over here and erase this. Okay. And remember, the top number goes inside the division sign. The bottom number goes on the outside. Okay, 3 will not go into 1. So again, I give myself a decimal and a 0. And then I put the decimal directly above when I start working through this. Okay, 3 goes into 10 how many times? Well, I know 3 times 3 is 9, which is really close. 10 minus 9 is 1. Okay, well 3 won't go into 1, so I'm going to give myself another 0 and bring it down. 3 goes into 10. 3 goes into 10. Oh, 3 times. 3 times 3 is 9. Put the answer down here. 9 subtract 1. Are you feeling a little bit of a deja vu here? You should be feeling a little bit of it. It's following the same pattern. And I only need to go out 2 to see that. But if you're not comfortable seeing the pattern yet, you can go ahead and do it again. See how each time I do this I get 10, 9, 10, 9, 10. Well, 3 is still going to go into 10 3 times, and the 3 times the 3 is going to give you 9. Subtract 1, and I'm going to bring down another 0. So once you see that pattern repeating over and over and over, we write the answer as 0.3 with a line over top saying that 3 is going to repeat forever because I can keep adding another 0. And so the answer is 0.3 repeating. And I'm going to erase this so that I can go to the next question. Okay, in this one I have 2/3. So I have a 2 here. Remember, the top number goes inside the division sign. I think I'm going to need a little bit more room, so I'm going to get rid of this 2 and make that look a little nicer. Okay, here we have the 2. It goes inside, 3 on the outside. Again, this 3 cannot go into the 2, so I need to give myself a decimal and a 0. And don't forget, in your answer, the decimal goes directly above on the division sign. 3 goes into 20. Well, I know 3 times 7 is 21. That's too bad. It's 1 short, so I need to go down 1. 6 times 3 is 18. Subtract. That gives me 2. Okay, so 3 still won't go into a 2, so I need a 0. Bring it down. 3 goes into 26 times. 6 times 3 is 18. Subtract. That's a 2. Are you feeling deja vu again? You should be. Every time I bring it down, I have the same thing as before. 20, 20, 20. It's going to keep being 20, which means this answer is going to keep being 6. So the answer is going to be 0.6 repeating. So you do 0.6 with the line over top. All right, that's how we change a decimal into a fraction, or a fraction into a decimal. So recapping, we take the top number, put it inside the division sign, the bottom number on the outside, give yourself a decimal, and tack on a 0 so that you can start dividing. Don't forget, the 0 or the decimal goes directly above the division sign also as you're working, so that your answer is right there. And that's your answer. Okay, let's move on to the next ones. More long division. Long division is one of those things that gets most students because it is involving all 4 operations: adding, subtracting, multiplying, and dividing. So it's all in one thing. So if you're getting a little frustrated and confused, you're not alone. It's one of those concepts that can kind of fluster some students. So just remember, take it one step at a time. Okay, over here, I've noticed that it's better if I write the question because then everything lines up better because my handwriting is bigger than the typewritten. Okay, so here we have our division, and what we like to look or need to look at, I'm going to close that up a little bit. What we need to look at is how many times will this number go into this. So 8 goes into 2. We look at the first number. It doesn't go into a 2, so nothing goes up here. So now I look at the next two. 8 goes into 25. 8 will go into 25, just a matter of how many times. 8 times, I'm going to let you think about it for a minute. 8 times, are you there? 3. 8 times 3 is 24. So we subtract. And what we did is we did 8 times, or 3 times 8, and we put the 3 over top of the last number that we worked with. 3 times 8 is 24. Subtract. 25 minus 24 is 1. Bring the next number down. We have 6. Now we look at 8 going into 16. Oh, that's nice. That's nice and even. And the answer's 2. And I make sure that goes directly above the last number I was working with. Then I do 2 times 8, which is 16, and subtract, which is 0. That means I'm done. So the answer is 32. There we go. Okay, let's move to another one. This one has decimals, and I'm going to need some room, so I'm going to erase some of this. Okay, so this next one, it has some decimals in it. Now, the decimals don't matter when they're underneath in the division sign. However, they do matter when they're on the outside. So this point, this decimal out here, that's a problem. We have to make sure that this is a whole number. So what we do is we simply move the decimal over 1, 2 place values. In doing so, that becomes just 6, which is good because we need that to be a whole number on the outside. I apparently didn't erase enough over here. Get rid of this so I can work some more. Okay, so now that 6 is a whole number. Good. But can I just go around, moving it over? Not unless I keep things equal. So if I've moved it over twice, 2 place values on the outside, then I need to move it 2 place values on the inside and in the exact same direction. So if I moved it 1, 2 to the right, I need to move this over 2 place values to the right as well, which means this really becomes 142.5. There we go. So now I can start dividing. And I look at this whole number 6, which we went to a lot of effort to make a whole number. 6 goes into 14 2 times. So I put the 2 over the 4 because that's the last number I worked with. 2 times 6 is 12. Subtract. 14 minus 12 is 2. And bring down the next number, 2. Okay, now 6 goes into 22, or 22 divided by 6 goes in how many times? 3. Again, making sure that this number is above the last number you worked with. 3 times 6 is 18. Subtract. 22 minus 18. Some of you are okay just to go ahead and subtract that. Some of you will like to borrow just to verify, and that's up to you. Some of you are going to say, oh, 18, that's 4 away. Some of you are going to want to do this and do 12 minus 8 and 1 minus 1. That's okay. It doesn't matter. Work at your pace, whatever works for you. Okay, so we get a 4. Now I come up to the top. Don't forget, there's the decimal, so I need to move that decimal and my answer directly above it. And drop down the 5. Now some of you are saying, hey, wait a minute, do I need to drop that decimal down? No, the only thing you need to worry about is making sure that there isn't a decimal out here and that in your answer, you've moved it directly above. That's it. So now we need 6 goes into 45 how many times? Are you there? 6 times 7. Good. 7 times 6 is 42. Subtract. 45 minus 42 is 3. Then I can tack on as many zeros as I need, right? So I'm going to bring down the next 0. 6 goes into 30. That's an even one. Goes in 5 times. 5 times 6 is 30, which gives me no remainder. And I'm done. So I don't even need to put on another 0, although I could if I needed to, but I don't need to. So the answer is 23.75, which matches over here. So I feel comfortable moving on. All right. I'm going to erase again, give myself some room. I think that should be enough. Okay. All right, same as the last one. Notice I have a decimal on the outside. What did we have to do? We have to move it over, making that a whole number. So in doing so, that number is really 14. There we go. Okay, and because I can't just, move things over, I have to keep things balanced. So I need to make sure this underneath also moves over the same number of times one place value. So this is really 1164.5. And some of you can go ahead and just move that up right now. The decimal, if you would like to, it's up to you. I think that's going to get in the way, so get rid of that too. Okay, so now we just work into it. 14 will not go into 1. 14 also will not go into 11. But 14 will go into 116. It's just a matter of how many. So we're going to go 14 times 8. And 8 goes directly above the 6 because it was the last number we worked with. And doing your multiplication, 8 times 14 is 112. There we go. Subtract. 6 minus 2 is 4. Perfect. Bring down the next one. 4. Okay, so now I need 14 to go into 44. In this case, it's 3. 3 times 14 is 42. Subtract gives me 2. Okay, making sure that my decimal went directly above in my answer. Good. Need to move the 5 down. Don't need to worry about the decimal down here in the working stuff. Only need to put it up in the answer. Okay, 14 going into 25. It only goes in once. So 14, subtract. 5 minus 4 is 1. 2 minus 1 is 1. And I know 14 won't go into 11, so I need to tack on another 0 and bring it down. Okay, now I need 14 to go into 110. So 8 was too high because that was 112. So I'm going to do 7. 7 times 14 is 98. Subtract. Some of you are okay just moving on and knowing that that's going to be 12. Some of you would like to go ahead and borrow, and that's up to you. 10 minus 8 gives me 2, and this we can look at as just being 10 minus 9 is 1, which gives me 12, and I can tack on another 0, bring it down. Now I need 14 to go into 120. So this one again, it's only going to be 8. 8 times 14 was 112. Subtract gives me 8, if you're comfortable with that. 20 minus 12 is 8. If not, go ahead and borrow. Okay, so I can give myself another 0. Bring it down. 14 goes into 80. 14 times 6 is 84, so that's a little too high. So we need to do 14 times 5. 5 times 14 is 70. Subtract is 10. I'm running out of room. And because I'm running out of room, we can see there isn't a pattern going on here. We're getting different numbers every time. So this is a non-repeating, never-ending decimal. So I'm going to just put the ellipsis ... just to say this keeps on going. There we go. 83.1785, and the ... is called the ellipsis, which means it's just going to keep on going, and we're not going to keep on going with it. The instructions will say in many cases where to round to. So if it said stop at the tens place, you need to go out one more so that you can, or tenths place, you need to go one more so that you can round to the tenths place. If it says go to the hundredths place, you have to go out one more to the thousandths to know what to round to if you're going to round up or down. All right, let's go ahead and move on. The next one. This is changing a fraction or a division into a percent. So the first thing we need to do is this, similar to what we did previously, which is divide. Change it into a decimal first. So what did we do? We made a division sign. The top number goes inside, the bottom number on the outside. Because 12 can't go into 3, I need to give myself a decimal and a 0. And make sure in your answer that the decimal is directly above the decimal underneath the division sign. Okay, so now we need 12 to go into 30. So that's going to be 2 times. 2 times 12 is 24. Subtract is 6. If you're not comfortable doing that right off the top of your head, go ahead and borrow. That's fine. Okay, 12 won't go into 6, so I need another 0. Ooh, 12 goes into 60 perfectly. 5 times. 5 times 12 gives me 60. So I'm going to subtract. There we go, 0. So I get this decimal, and you're thinking, okay, well, it said change it into a percent though. The direct translation of percent, per means this part divided by. Cent is 100. And those of you who speak a Latin-based language, Spanish, Italian, French, those all have some form of cent, which means 100, or those of you who are in the United States, cent, we have 100 pennies or cents in a dollar. So that's one way of remembering cent. So this means divided by, per 100. Okay, so how does that help us? There are 2 zeros in 100. So to change the place value to make it per 100, you take this decimal here and move it 2 place values, because how many zeros does 100 have? 2. So I move it over 2 times, which makes it 25%. Somebody in one of my classes had mentioned that the 2 zeros are similar to the percent over here. It looks like the zeros from the 100. Now it's not, it's just a percent sign, but it's one way to remind yourself that there are 2 zeros, which means that it changes the place value by moving your decimal 2 places over. So it's 25%. Again, I'm going to need some more room to work. Get some of this out of here and go back. Okay, so now my next one, I know I'm going to divide. The top number goes inside and the bottom number goes on the outside. Because 20 won't go into 11, I must add a decimal and a 0. And don't forget, the decimal for the answer goes directly above. Okay, 20 into 110. Okay, so I know 20 times 5 is 100. So that's as far as I can go. 5 times 0, if you're struggling with that, 5 times 0 is 0. Then 5 times 2 is 10. Subtract gives me 0 and 1 and 0, so good. I have 10. So I need another 0 to bring it down. 20 into 100, hey, that goes in perfectly. 20 into 100 is 5. 5 times 20 is 100. Subtract is 0. So the answer is 0.55. That's perfect. And how do we change that to a decimal? Or to a percent? Move the decimal over 2 times. So I have 55%. Perfect. Uh, this video lecture seems to be getting a little longer, so I'm going to call this the end of part 1 and start up the next part for part 2.